Hi, everyone. Welcome to Chapter 3. Chapter 3 describes and explores and compares data. The first section that we're going to look at is called Measures of Center. That is section 3.1. That's what we're going to be focusing on today. What is the key concept? The key concept of this section is to focus on obtaining a value that measures the center of the data. In particular, we're looking at the mean and the median in this section. Our objective here is not only to find the value, but actually interpret what those values mean. Remember, the purpose of statistics, the purpose is to understand and interpret values and not just numbers. Okay. So we're looking at more specific, we're going to look at the mean and the median of different values of data. Let's talk about the definition of a measure of a center. The measure of a center is the value at the center or middle of the data. So it's going to be found, it's going to be centralized at one place. It's going to be the actual middle of the data. The definition of a mean, most of you are familiar with a mean. The mean or the arithmetic mean of a data is also measured of center by adding all the values and dividing it by the total number of data values. So if I give you an example, if I want to find the mean of 1, 2, 3, 4, 5, and 6, I have to add all of the values. So 1 plus 2 plus 3 plus 4 plus 5 plus 6 all over 1, 2, 3, 4, 5, 6 values. So if I add 1 plus 2 plus 3 plus 4 plus 5 plus 6, well, 1 plus 2 is 3, plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21, all over 6. So 21 over 6 is 3.5. So 3.5 would be the mean of the data of this example. What are the important properties of the mean? Well, the sample means are drawn from a sample population, tend to vary less than other measures of center. The mean of the data, it actually is going to use every data in the values. So every data value will be used. What is the disadvantage of the mean is that it's just a one extreme value. It can find outliers. So the mean is something called non-resistant. So if you change a value, then this can definitely impact your mean. So if I say, well, 1, 2, 3, 4, 5, 100, right? Before my mean was 3.5. Well, now if I want to find the mean of this is going to be 1 plus 2 plus 3 plus 4 plus 5 plus 100 all over 6. So how will that change the mean by only a simple value? Well, 1 plus 2 plus 3 plus 4 plus 5 plus 100, right? It's 115. Divide that value by 6. So 115 now divided by 6 is going to give me 19.2 roughly. So see how just by changing the number from a 6 to a 100, my mean drastically changed. So when something drastically changes, that means that it's non-resistant. Okay, so the mean is non-resistant. The definition of resistant is a statistic is resistance if the presence of an extreme value. So in the last example, the extreme. So in the last example, the extreme value was 100. versus 6, right? So the extreme value was 100. Now that is called a outlier because it will change, obviously, the value of the mean, where we want resistance in statistics. We want to preserve the value even though we add an outlier to it. What is a notation? This notation means sum. That's like a Greek letter. So this symbol is the Greek letter for sum. For summation, you're adding the values. Or another word is called sigma. So sigma in our notation, if we're looking for sigma notation, denotes the sum. So X is the variable that's represented for each individual. So for example, X1, X2, X3, ... Those represent the data values. N represents how many, the number of data values in a sample, and big N represents the data values of a population. So little n represents the number of data value in a sample versus big N is the number of data in a population. Remember that population, little n will always be smaller than big N because the number of population is always greater than the number in a sample. Remember, a sample is just a handful of what's represented in a population. You can also see that there's a difference between X bar and mu. So X bar, it means the mean of a set in a sample value. So it means the sum of little x all over little n, where mu, this Greek letter mu, that looks like an M, is represented by the mean value of a population. So the big difference is, so what is the difference? The difference is the division. Is the division, oops. It's the division between the sum of your data values. One is divided by little n. The other one is divided by big N, right? That's the difference between the two formulas, X bar or mu. So what we're going to do is we're going to do an actual example of finding the mean. And let's look at this example. Data set 32 airport data speeds in Appendix B includes measures of data speeds of smartphones from 4 different carriers. Find the mean of the first five data speeds for Verizon. So remember, this is a sample mean. How do I know that this is a sample mean? We're only grabbing the first 5 data speeds for Verizon. Not all of the speeds for Verizon, but just a few. So what we need to do is we're going to sum the values of x all over little n. Well, what's the sum of n's? Well, each x is x1, x2, x3, x4, x5. So 38.5 plus 55.6 plus 20. And then you will have a calculator. So if you have it, please pull it out. Plus 23.1 all over. Well, how many? 5. Now, what we're going to do is I'm going to show you that there is a free calculator that you guys can use. And it's called Calculate 84. If you have an Apple computer or if you have an iPhone, and if you don't have a graphing calculator with you, I do encourage you to download this Calculate 84 business. that it can help you out how to find mean, median, mode. Very simple, and substituting using this as a calculator. So the name is called Calculate 84. And one of the things that you guys can do is you can input your stats and then select edit. You can remove L1. So L1, you're going to select delete, and then L2, you're going to select delete. All you're going to use is L1 because you have a data of one value. So I'm going to input my data 38.5 and then enter, and then 55.6 and then enter. And then I have 22.4 and then select enter, and then 14.1 and then enter, and then 23.1 and enter. So again, I hit stat, edit, and then I'm going to list my values. So 38.5, 55.6, 22.4, 14.1, and 23.1. Now that I have this, I'm going to hit stat again. I'm going to say calc, and I'm going to say one vars stats. I'm just going to hit enter and then enter again. And then it's going to actually tell me, if I go up, this X bar business. X bar is the mean that you're looking for, 30.74. So my answer is 30.74. If I wanted to find the sum of my values, that would be 153.7. So all you're looking for is this X bar. X bar is the sample mean, 30.74. And that is the answer. Again, what did I do? I selected stat, edit, input my data, and then hit stat again, and then calc, and then one var stats. This will also work if you have a TI-83, TI-84, and then you're going to hit enter, and then enter again. It's making sure that the list that it's retrieving should be L1. Hit enter, and then you're going to scroll up a little bit, and then you're going to see this X bar right there. So X bar is 30.74. So I'm going to go back to my notes. So again, you're looking for your sample mean, which is your X bar. We used calculate 84 as our graphing calculator online for free, or it's an app that you guys can download. So there it is, 30.74 megabytes. That is the sample mean of this example. Okay. Now, caution, never use the term average when referring to measures of center. The word average is often used for mean, but it's sometimes used as other measures of center. The term average is not used by statisticians. The term average is not likely to be used in statistics, communities, or professional journals. So for us, average versus statistics is not the same. In measures of center. So when we're looking at measures of center, we want to focus on the word mean, not average. Now let's talk about median. The median of a data set is the measure of center, that it's the middle. It's in the name. It's the middle value of the original of data values that are arranged in order of increasing to decreasing in magnitude. So we always want to make sure that we have the values in order. So we want to make sure that the values of the data set are in order from decreasing to decreasing. Okay, so it's always in order. What are the important properties of the median? The median does not change by large amounts. We can conclude that even when we add extreme values, the median is a resistant measure of center. So if we go back and we say, well, what's 1, 2, 3, 4, 5, and 100, right? We are going to add the outlier. Well, if we're trying to find the middle value, well, cross, 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 cross. We have two numbers in the middle. We have to find the median, which is going to be 3 plus 4 over 2, which is going to be 7 over 2 or 3.5. So that's not going to change if it's 1, 2, 3, 4, 5, or 6, because the middle value will still be 3.5. So we can say that the median has the property of being resistant, because even though we added the outlier, it did not change the value of my median. So the median does not directly uses every data value, right? That's the difference. So what's the difference? When we're looking at the mean versus the median, well, one of the differences that we talk about here in lecture is that the mean uses all the data values, whereas the median does not. Right? It does not use all of the values. We're just focused on what's the middle number. Well, we're going to look at the notation, what notation is being used. So remember, X bar is mean, X tilde, where it has this little, this is X bar, and then we have X tilde. So this is the median. When we're looking at the X tilde business, X tilde will give us the median of the data. Okay. And we're also going to be able to find the median using our calculator. So to find the median, we first are going to sort the data values. We're going to arrange them in order, and then we're going to look at the following two procedures. If the data value is odd, then the median is located exactly in the middle. If it's the value of it is even, then we are going to compute the mean of the two middle numbers in the sorted list. So that's what we did over here. When we were looking at the example from 1 through 6, 1, 2, 3, 4, 5, 6 is an even number. So we had to add, excuse me, we had to add 3 plus 4 divided by 2 to give us the median. And that was 3.5. And that's because 6 is an even number. Now, if it was odd, then things changed. So if we do 1, 2, 3, 4, 5, 6, 7, now the actual middle number would be 4 because we cancel, 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 cancel. 4 is our median if we add one more number. So it changed from 3.5 to 4 because we added the 7. So we added, when we added one more number and made it odd, then our median changed. It was now the middle number versus having to add and divide by 2. Okay. Now we're going to look at the same example we just saw from the median with an odd number of data values. So let's look at this example. 1, 2, 3, 4, 5. This is the same example that we used. So we're going to go back to our calculator. Remember that we had stat here and then edit. And then when we set enter, look at the data. 38.5, 55.6, 22.4, 14.1, and 23.1. I want to be able to find the median. What if I don't want to put it in order and just having to cross things out? Why can my calculator do it for me? Can it? Yeah. So you're going to do stat, and then you're going to hit calc, and then you're going to hit once var test, and then select enter. And then you're going to see this med thing. Med. So you're going to select on enter, and you're going to look at med. The med represents the median in our calculator. So in our calculator, we're notice without having to do any computation, without having to put it in order, we notice that the median of the data is 23.1. So when we go back to our notes, again, we're using our calculator. We notice that 23.1 was the answer for the median. What they did in the notes was they sorted out the values, so 14.1, 22.4, 23.1, 38.5, and 55.6. They said, okay, well, cancel, 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 cancel. There's my middle number, 23.1. And I knew it was going to be at the middle because we have an odd number of values. We have 5 to v my values of n. So what does that mean for us? That we can compute mean and median very fast without having to do any sorting, adding, or anything using, again, our Calculate 84. And you are allowed to use this when you're doing your quiz. You are allowed to use Calculate 84 when you're doing your test. You are allowed to use a calculator in this class. Now, repeat this previous example using a 6 data of 24.5. So now what we're going to do is we're going to add a value. So not just 38.5, 55.6, 24 point, 22.4, 14.1, 23.1, and 24.5. We're going to add a value. So to add a value, you're going to go to your calculator. You're going to go to Calculate 84. You're going to go to Stat, Edit, and then you're just going to put it below. So the number was 24.5 megabytes. And then you're going to hit Stat. So once you've inputted your 6th value, and it should say L16, that means your 6th value. And then you're going to hit Stat, again, Edit. Oh, sorry, Stat, Calc, 1 vars test. Then you're going to hit Enter, and then you're going to look at the med, look at the median. The med, because right now we're focusing on the median, is 23.8. So it changed from 23.1 to 23.8. And that's because we added a 6th value. So the median, the med, is 23.8. So there it is, 23.8 megabytes. They found the median by, you can also have a cross, put this in order, cross, 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 and then you have 2 numbers in the middle because this is an even number. So 23.1 plus 24.5 divided by 2 give us 23.80. But sometimes when you're doing your homework, there's going to be more than just 5 values. So that's why I'm showing you how to use a calculator. Now mode is the value. Most of you are familiar with finding modes. The mode is the value that occurs most in frequency, which one is shown the most in the data. So if I do 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 6, 6, out of this one, which is the mode? Well, 6 is your mode. 6 is your mode because it shows up most in frequency. Because there's 2 1s, there's 2 2s, there's 2 3s, there's 2 4s, there's 2 5s, but there's 4 6s. So predominantly the data that shows the most, that occurs in more frequency, is 6. What are the important properties of a mode? Well, the mode can be found by using qualitative data. The data set can have no mode, 1 mode, or multiple modes. So an example of a no mode would be 1, 2, 3, 4, 5. They all show up one time. So this is no mode. There's 1 mode, and that's the example that we saw. That was 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and then 6, 6, 6, 6, and 6. And then this was 1 mode, the 6. And then I can have multiple modes. The multiple modes could be something like 1, 1, 2, 2, and 3, 3. Well, they all show up twice. So the mode would be 1, 2, and 3. So you can have multiple modes because they show up the same amount of time versus 1, 2, 3, 4, 5, which is, it doesn't repeat. You don't have anything that repeats. Okay. A data set can have one mode, more than one mode, or no mode. When two of the data sets occur in the same greatest number of time, we can have something that's bimodal that occurs more than twice. It's called multimodal. And then when no data value is repeated, we say that there's no mode. So a bimodal, you can have two modes, just two, right? Just two. So a bimodal, it's just only two data values, not more than two. So a bimodal, we didn't have an example of a bimodal here, right? We just said no mode, one mode, or multiple modes. But a bimodal would be something like would be something like 1, 1, and 2, and 2. So my modes would be just 1 and 2, right? Because there's only two data values. Or you can have 1, 1, 2, 2, and then 3, and then 4, and then 5. You still have a bimodal. The bimodal would be 1 and 2. Right? So let's look at this in example. We're trying to find the mode. We see it's kind of already kind of highlighted. 0.3 shows up the most. A 0.6 shows 2 times, but the one that dominates, it's 0.3, right? Because it's seen 3 times. We can have two modes, which is 0.3, 0.3, 0.6, 0.4, and 0.4. Now, 0.3 and 0.4 show the same amount of time. So there's two modes, or bimodal. This is a bimodal example, right? 0.3 and 0.4. You can have no modes where no of the values are being repeated. 0.3, 1.1, 2.4, 4.0, and 5. None of them repeat. That means you do not have any modes. We also are going to be talking about something called a mid-range of a data. The mid-range is actually the measure of center. It's another type. It's a measure of center. That is the value midway between the maximum and minimum points. So be careful. A mid-range versus median are not the same, right? So they're not the same. Because first of all, when you're using a mid-range, you're only looking at the max data, adding it to the minimum data, and dividing it by 2. That's how you find the mid-range. Now, what about the mid-range? Is it resistant or not resistant? Well, no, because the mid-range is actually very sensitive. It's very sensitive because if I just change a maximum value to a minimum value, then that's going to impact your solution. Let's do an example. Let's say I have a data 1, 2, 3, 4, 5, and 6, right? I'm going to find the mid-range of this example. So I'm going to take 1 plus 6 and divide it by 2. 7 over 2 is 3.5. That would be the mid-range of this example. Now, if I have an extreme value, let's say 1, 2, 3, 4, 5, and 100, I keep using the same example. I'm going to do 1 plus 100 divided by 2. So that's going to be 101 divided by 2, or if I'm doing 101 divided by 2, we get 50.5. So 50.5 versus 3.5, not resistant. All right, we're not, as long as I just change, or if I would change my minimum value, that would also change. What are the important properties of a mid-range? Well, in practice, the mid-range is actually rarely used, but it does have 3 redeeming features. And what are those features? Well, one of them is actually very easy to compute. The mid-range helps reinforce the importance of one point that there's several ways to define the center of a data. The value of the mid-range is sometimes incorrectly used for the median, so confusion can be reduced by clearing up the definition along with the median. So remember, the difference between a mid-range and a median, one of the differences is that the mid-range does not, it's not affected by even an oddness, right? Whereas the median is affected, or the way that's computed, by even and odd. Another thing is that the mid-range is resistant, is not resistant right? Versus the median, which is resistant. So those are the two differences, right? The mid-range is not affected, so because you're just taking the corner one, so it doesn't matter if it's odd or even. Whereas the median is affected because then you're going to have to completely use different formulas, and the mid-range is not resistant, whereas the median is resistant. So let's look at the example. What is the mid-range for this data? For this example, if we're trying to find the mid-range and we already have them in order, all we have to do is just, this one doesn't really take a lot of computation because you're only grabbing 2 data values instead of all of them. Well, we just look at the maximum data, which is 55.6, plus the smallest data, which was 14.1, divided by 2, and we get 34.85. So we notice that, first of all, our computations are different. On one example, we got 34.85, and for the other one, so the mid-range for this example is 34.85, whereas the median, if we recall, it was 23.1, I believe. So if we go back to the example that we did, and we were looking at the median of the data, it was 23.1. So even in our computations are different. So one example give us the mid-range 34.85, median was 23.1. Okay. Now let's talk about the round-off rule for measures of center. What does that mean? What is a round-off rule? Usually when you're looking at statistics, it's not going to be a whole number. It's probably going to have some decimals. And there exists some rules to use a round-off rule when we're looking at measures of center. So when we're looking at mean, median, and mid-range, we usually carry one more decimal than what's presented on the original value. So for example, if I have 1, 2, 3, 4, 5, and 6, and let's say I want to find X bar, which is the median, which is the mean. We want to find the mean. We want to find X tilde, which is the median. And we want to find the mid-range. Here, notice that the mid-range doesn't have an actual like notation. Does not have notation. But if we're looking at the mean, right? If we're looking from 1 through 6, and we want to find the mean of that. For us, we're going to do one more round-off rule. What does that mean? Well, the round-off rule, if we're looking at, well, what's 1 plus 2? We have 1 plus 2 plus 3 plus 5 plus 6, right? 21. And then that gives us 21 over 6. We get 3.5, right? We're looking at the median. How do we find the median? We cross, 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 and we get 3.5. It's because it's an example. And then lastly, if we're looking at the mid-range, 1 plus 6 divided by 2, we get still 3.5. So for this example, they're all the same, but I purposely selected this example. Right? Now, notice that all of these are one more than the original data. So we're not rounding to the nearest whole number, and we always carry one more. So if the original data was, it's a whole number, we do one more. That's one more decimal place. Now for the mode, we leave the value without rounding. So for us, 1, 2, 3, 4, 5, and 6. Well, this one does not have any mode, right? For this example. But let's say we would have 1, 1, 2, 3, 4, 5, and 6. Well, the mode does not need a round. That's what this is saying. So the mode for the second example would be 1, but we would leave the value as is. We wouldn't round one more. We would use the original data value. So let's look at the critical thinking aspect of this example. We can always we can always calculate measures of center from samples of the numbers, but we should always think about whether it makes sense to do that. We should also think about sampling method used to collect the data. Remember, what do I mean by sampling method? Is this a convenient sample? Is this a random sample? What type of sample are we looking for? And then how are we collecting the data? That's very important. So when we're looking at statistics, we need to look carefully at what does each value represent and if they're coming from a reliable source or not. Are they coming from a sample that is a reliable sample versus just something that we're just trying to study? So let's look at this example. See if the following illustrations, if we're looking for, let's say we're looking for the mean and the median, right? And they're giving us an example of a zip code. And they're giving us different locations of St. Louis, like the White House, Air Force Division of the Pentagon, the Empire State Building, and the Statue of Liberty. Why are we interested in finding the mean or the median of non-meaningful statistics, like zip codes? What are zip codes going to do for us? This just means these are labels or geographic locations. They actually don't represent any measure whatsoever. So zip codes are not a measure. So this statistics would not be meaningful for us. So we would not be looking for type of measurements. Now, same thing here, rankings. See the following illustrations are also non-meaningful, like rankings in the university, like Harvard, Yale, Duke, Dartmouth, and Brown. So depending on the US news, if we have, let's say Harvard comes in second, Yale in third, Duke in seventh, and then Dartmouth in 10th, and Brown in 14th. So we're just given numbers and, oh, here, find just the mean and the median. No, well, we have to see what this means. So rankings does not have any meaningful statistics either. Rankings are also not measures of center. They just reflect order, but they don't measure anything. So it's also not a measure. So again, if we would just look at these numbers and like, oh, here it is, take this. No, we actually need to make sure they represent something. They represent a measure.